Hey, what's happening, yo? Some more kooky flat earth type talk, right? Recently I've been doing a little bit of the knowledge against flat earth, actually. I've done this before. As many people that at least consider the flattish earth model a possibility, which is as far as I could go. I could never say for a fact, yeah, we live on a plane, there is no space. I just say it's interesting to think about, and there's compelling evidence, air quotes around evidence, that suggested, and there's things in the globe model that just do not make sense when you break it down. However, this is one interesting thing, right? Mathematics, the math, right? Math is perfect. They say numbers don't lie, people do, right? Math has a certain poetic perfection to it. You make these equations, they come to conclusions. So, for example, in summary, let's say like the math that they do on gravity, the math that they do on Earth's curvature and stuff like that. Much of this math, even though it is above my head, I'm not a advanced trigonometry type person, advanced geometry, things like that. However, science over the decades, over the centuries, has put the stamp of approval on a lot of this math that makes perfect sense. Gravitational constants makes perfect sense. This, that, the third. So, when you want to consider the Earth being flat or space not being real or anything like that, you have to ask yourself, all right, we have this perfect math that fits into perfect equations in favor of a globular model or in favor of the existence of gravity, stuff like that. Now, is it possible that someone can, I don't want to say fabricate, but can make these equations, right? Like if you were to reverse engineer these equations, is it possible that these equations can exist and not be connected to nature? Meaning let's say gravity is not real. However, the equations they create for gravity make 100% sense, and gravity still not being real. Or is it the fact that these equations make 100% sense? Is that confirmation enough to say, well, yes, gravity is real? You know what I mean? It kind of goes to a philosophical level there, right? Well, here's one interesting thing. What you're looking at now is a balloon flight that went up to 120,000 feet up. Let me go to the video to make sure this thing's moving. Okay, it allegedly went to 100,000 feet up. And as you can see, the camera's panning back and forth. Now, a lot of people that consider the flattish model of our Earth, they defer to this. This is one of the premier things. This might be the spokesman for flat earth if we have to pick visuals, right? You could see it's like the camera's panning. Allegedly, you see Earth's curvature significantly once you hit 70,000 feet, right? Above where a plane goes. I've been to anywhere between 40 and 50 flights, and I could tell you I've not noticed any curvature, even though they have fisheye lenses, thick fisheye lenses out the window that can contort it into curvature, right? But this is 120,000 feet up, supposedly. And as you can see, you see a lot of flatness there, even as the camera pans. Just one still shot, like if I pause it, from left to right, you should be able to see curvature, according to the math of what they say our Earth is, right? So not only do you not see curvature there, you see the camera moving around and you still see flatness. Or do you? Do you continually see flatness? Because here's another thing to think about, right? I don't know if you're going to really notice it that much in this video, but as the air balloon or whatever that is moves, the image does kind of contort. Like sometimes it gets slightly curvy, and then sometimes it gets convex, when it looks more like a skateboard ramp, like an inward curve or whatever. It actually does that, especially toward the end. You really see it here once the balloon pops. Let me find the spot. You really see it. Where we at? It's toward the end. See? It gets real wobbly there. It gets, because the balloon popped and I guess the thing is falling, so the movement causes a wobble, right? And you could see slight curvature, as it's panning back and forth, right? So what I'm saying is, does that disqualify this video as proof of a flat plane? Just the fact that any curvature can occur that's unreal, or any distortion can occur that is unreal, does that now disprove this as an eligible contender in favor of flat Earth? Because who's to say that when it's at its flattest, that is the true image if it does in fact distort? So you can see it right there kind of curving a little bit. Who's to say which one is the actual true image, right? Now, something kind of against that, I will say this. It seems like the distortion is constant with the moving of the camera. Like the more still the images are, it appears that it doesn't distort or it doesn't move much. And the more still the image is, it seems to be a generally flat plane. So there is that. However, the fact, it's still, an inkling of doubt. Just the fact that it has any type of wobbling or distortion, period, does that disqualify the whole thing? To me, it doesn't give it that 100% stamp. Oh, this is truly a flat plane based on this. In fact, even if it didn't do that, I still wouldn't give it that stamp. You know why? Because I'm watching a YouTube video. How do I know that it went up to 120,000 feet? How do I know that this wasn't some big illusion and the video's been altered? I did not perform the balloon test myself. You know what I mean? Boom. So there's that. Another thing that kind of goes against the flat Earth. Well, I'll tell y'all the biggest thing that always had me saying, well, I can't just 100% say I rock with this flat Earth type thing. You know what I mean? The biggest thing for me, because it's the one thing that I never found a sound explanation for, and that is the constellations. If you're on the alleged northern hemisphere, you see the North Star, and you see a set of constellations, right? And they have the appearance to move in one direction. If you're on the alleged southern hemisphere of the Earth, you see a whole different set of constellations that move along the Southern Cross, and they move in the opposite direction. Now, on a spherical Earth, that makes perfect sense. On our flat plane, supposedly, I have not heard a viable explanation for that yet. You feel me? Another one that I found interesting is look up Foucault's pendulum. Focault''S. I believe that's how you spell it. Foucault's pendulum. Basically, it's a pendulum that it's like a ball on a pendulum that's swinging back and forth, back and forth. However, the novelty of it is supposedly it's set up in a way where the swinging of the pendulum is outside of the rotation of the Earth, meaning the rotation of the Earth does not have any effect on the movement of Foucault's pendulum. And due to that, people have observed that if you let the pendulum swing over time, like after an hour, a day, whatever, as the hours go by, the Foucault's pendulum, as it still does its back and forth swing, but it appears to move in a certain direction, as it's swinging. And people have claimed that verifies the rotation of the Earth, because the Foucault's pendulum is not in sync with the rotation of the Earth, right? Now, my question is, why is that? Like, if that is actually true, that's compelling evidence that suggests at least a rotation of our plane, planet, whatever it is, right? But then I got to ask, what is it? I got to look into the mechanics, which I haven't done yet, the mechanics that go into creating a Foucault's pendulum, and I need to have an understanding of why the swinging of the pendulum is outside of the rules and the parameters of Earth's rotation. Why, if everything else is in sync with the rotation, planes in the sky, whatever direction they fly in, they also move along with the rotation of the Earth, our atmosphere, everything, us, every other thing that we know about is in tandem with the rotation. What is it about Foucault's pendulum that makes it like a played out record and takes it out of rotation? You know what I mean? But that would be compelling evidence if it in fact is, I guess, static, and it just stays there and does not move along with the curvature. That would be compelling, right? But then on the flattish side, we have a host of other things that just don't make sense. In fact, one of the biggest things that got me into considering about the flattish model of our plane, planet, whatever it is things that are a distance that's allegedly supposed to go over the curve that we're not supposed to see. People could zoom in and bring it back. Okay. People that argue in favor of the globe, they did bring up a point that even flat earthers admit to, and that is the mathematics by which we calculate the rate of curvature and the distance of when things curve, that those mathematics are bogus, it's faulty. What is it? 8 inches by squared, something like that. Look it up. But that's allegedly not the rate of curvature. And then someone came with an actual real rate or alleged real rate of curvature that means that it would curve. Basically, long story short, when people take those cameras at sea and zoom out and find something that goes out of eyesight, and then they zoom it and bring it back in with the focus of the camera, at first, it was thought that that stuff was coming back into view and wasn't supposed to be seen because it was way past the curvature. But allegedly, according to the actual math, it has yet to have went past where we're supposed to notice curvature. And if you keep zooming in on it, it will eventually go out of view, and it'll go out of view from the bottom up, meaning it'll start disappearing from the bottom up, which is to suggest that it's going over the actual curvature of Earth. But and I've watched this in a video, but what I still don't understand is how come things that go over the curve, let's say tall buildings, you can't see the bottom of it because a lot of it is over the curve, but you could still see like some of it. How come it still looks 90 degrees to the person looking at it? It doesn't look like it's leaned back. It doesn't, you know what I mean? You look at something way out on the left, it doesn't look like it's leaning toward the left over the curve or leaning toward the right over the curve. They always look 90 degrees straight up. You know, to me, that doesn't make sense if we live atop spherosity and things are going over that sphere. You know what I mean? So I just found that interesting. Maybe, you know, people will probably say, oh, it's something to do with refraction. They probably got a crazy equation for it, you know. I still do subscribe to the philosophy of our senses and things being a lot more simple than people make it to be. However, that does not necessarily disprove certain perfect math that humans have discovered, because who's to say that that's not really simple? You know what I'm saying? We're talking advanced math. Who decides what's simple and what is not simple? You know what I mean? The fact that humans are able to come up with these calculations and create of it, does that by virtue not make it simple there just on the strength of that? Just because a human can do it? You know what I mean? I don't believe there's a limit. Oh, you can only be this smart. Once you know stuff beyond that, it's complicated. You know, it's like the people that talk about, oh, why you use big words? Well, big words to who? You know what I'm saying? So just thought I'd chop it up about that real quick. But yeah, look at this. Back and forth, back and forth. So yeah, so what if the actual true image of this does show curvature, but it's not really seen due to the wobbliness of the camera? And then again, see, you can see it right there. You saw like a little convexity right there. But then again, when the camera's at its most stillest, it does appear to be perfectly straight. But then again, I'm watching a YouTube video. I did not shoot this balloon up. I don't know that it's 120,000 feet up, you know. All right, enough of this ramble. Tell me what you think about all that.